Welcome back, compadres. I'm Brandon Tolbert, and today we're talking programming. If you're thinking about building large-scale software systems or GUIs, you need to understand object-oriented programming. It's not that easy to understand, though, because in school they discuss it from a software side. So today I'm going to apply object-oriented programming to a mechanical engineering example. We're going to discuss UML diagrams and classes, and we're going to develop a program to calculate stresses in beams of varying cross sections. So we're going to look at bending moments and worst case shear stresses in beams of different cross sections. So guys, let's get started.
So the objective is to write an object-oriented program to calculate the worst case bending and shear stresses in a circular beam, rectangular beam, and circular tube. So the situation we're describing is depicted here. It's a beam that has bending loads acting on it. So this is an example of that, an end-loaded cantilever beam. And so for this situation, what we're doing is we're trying to determine the worst case shear stress and the worst case bending stresses. So for example, if this was a beam with a rectangular cross section as shown here, the worst case shear stress would occur in the middle of this beam under this load. And also the worst case bending stress would occur at the top of the beam and bottom of the beam. And they have opposite signs because one side of the beam is in compression and one side of the beam is in tension. So this is the situation we're going to do today. We're going to do it for varying cross sections. So some key concepts I want you to think about as we go through this is UML diagrams. This is kind of the first approach to developing a object-oriented program. It's where you brainstorm and you list your parameters and functions and all that. And also constructors. Constructors is a term in software engineering that basically is used to initialize the parameters and fields that go into the class. So just keep those two things in mind as we step through this. So before you get started with object-oriented programming, you have to understand or be familiar with a UML diagram. This is the brainstorming piece right here. If you can do this, you can basically construct any program. So on the software engineering side, there's a slightly different definition and it doesn't really apply to what we're doing here. So I've created an alternate definition for mechanical engineers or engineers in general when performing or programming calculations in object-oriented programming approach. So the software side in the academic world can be a bit confusing because it defines objects as physical entities. We don't always have that. For our case, we're using calculations. So the software definition includes a class, which basically is a template that defines an object. And then you have your data fields, which is attributes of that class. For example, an object could be a circle or a rectangle. So the attributes of a circle could be the radius and the color of the circle. And then you have a constructor to initialize or create that object and actually initialize the data fields too. The color of the circle, the radius, you define that here. And also you have methods that describe the behaviors of the object. So for a circle, if we use that same analogy, you may want to know the area or the perimeter. So the definition I'm going to apply is shown here to the right. We still have the same components, but defined a little bit differently. In our case, the class is a template for a calculation. And also the physical or the data fields, I change those to physical parameters. So they're your inputs. What variables go into your calculations? That's what you include in this box right here. And then you have your constructor, which is used to pass in the parameters or initialize the parameters. And then you have your functions, which perform the calculations and give you your outputs. So that's kind of a different way of thinking about a UML diagram in engineering terms. I find this way a lot more convenient in what I do. So this is the definition I'm going to apply. So before you get started, you need to lay out all your equations and the variables you need. So for our case, we're calculating bending, worst case bending and worst case shear stresses in beams of different cross sections. Here I've shown a rectangular cross section, circular cross section, and a tubular cross section. And so what you have is we're going to need moment of inertia. of these cross sections to calculate our bending stress. We're going to need the max shear stress equations and also the bending stress equations. So for a rectangular beam, the moment of inertia is this, the max shear stress is this, and you can find this in a mechanical engineering or mechanics of materials textbook. And so for the circular tube, we have the same things with alternate variables. So these are the equations I'm going to apply in building my object-oriented program. So once we've kind of listed out the variables and the equations, now we can begin to brainstorm with our UML diagram. In this case, we're going to have three classes. One to calculate bending stresses in rectangular cross sections, one to calculate stresses in circular cross sections, and one to calculate stresses in circular tube cross sections. So what I've defined here is our parameters. So I'm going to need the width, the thickness, the bending moment, and the shear stress. I'll get these from my shear and bending moment diagrams. And then I'm going to initialize these values, these parameters, with a constructor. In Python, we're going to use your constructor is defined as this right here. That's just the syntax and nature of Python. You have to know this. You can't change. And so then I've defined the functions I'm going to need to make my calculations. I'm going to need to calculate area of this rectangular cross section. I'm going to have to use my moment of inertia equation, my max shear stress equation, and my bending stress equation defined in the previous slide. The same for circular stress. We're going to need outer diameter, and the bending and shear stresses, bending moment and shear stress is from our diagrams, bending and shear stress diagrams. And then we're going to initialize those and then calculate the area, moment of inertia, max shear stress, bending stress. These are our functions. And then for a circular tube, we're going to need outer diameter and inner diameter, and pretty much we're going to do the same thing here. So this is kind of what you do to brainstorm this. Now we're going to actually go apply this and build a program. So let's go over to Python. So the first thing you want to do is create a new project. So go to File, New, Other. We're using Python with PyDev plugin. I want to create a new PyDev project. We're going to call it Bending Stress. And if you don't know how to get this up, say no. I don't want to open the perspective, but you can go look at my previous video. I show you how to install Eclipse in the PyDev plugin. So just go watch that video. So after we have created a Python project, let's go open up a new module. And we're going to call it Bending Stresses, the package Bending Stresses. And then we're going to call this module, we're going to call it Bending Stress. Let's just call it Bending Stresses. Yeah, let's do that. Okay, so now we're ready to go. We're ready to code. So let's go back and look at our UML diagram. So what I've done here, I'm going to double click that, and then I've took a snippet of our UML diagram of one example. So we're going to do our rectangular stress class first. This calculates the stresses in a rectangular cross-sectional beam subject to bending loads. And so the first thing we want to do is define the class. So class rectangle stress. And then now we have to, as shown here, we have our parameters, but we got to define these in a constructor. So to create a constructor, what we do is we type in this code, init, you press enter, it initializes it, and then you always have a self here because it's referring to the object. That's how it keeps everything stored in memory. And so that's just the syntax of Python. I'm defining the parameters in this UML diagram. We're going to need width, thickness, bending moment, and shear stress. Bang. And so how do we initialize these? Well, we have to use the self dot width. So this is our parameters, equals width, self dot thickness, and it can be any name. You just got to use self because, like I said, in object-oriented programming, it's a little bit, you have to keep things stored in memory, and this is how you keep those parameters tied to the object, is by defining it with the self. And so bending moment, and then we have to do our shear stress. And I'm just pressing enter to autocomplete the code. It's actually keeps these things that once you type it in, it knows how to complete it. Eclipse is very smart in what it does. That's why I use it. So we've defined our parameters, and we've initialized those parameters in our constructor. The next step is to define our methods. So we just define our methods like this. And all I'm going to do is return the area of a rectangular cross section, which is going to be just the width times the thickness. We're done there, and now we want to define our moment of inertia. And these equations are in the slide. So if you don't remember, go back and look that up. Inertia. And then we're going to return our value, which is going to be 1/12 times the width times the thickness and we're going to cube that, raised to the third power. That's how you raise a variable to a power in Python, is you use double star. Now we're going to calculate or define our max shear stress function. And we're just working down the list here on our UML diagram. I mean, that's why you make UML diagrams, so you can just fly through your code. You've defined it in the order you need to define these in, and bang, it's pretty easy. So our max shear stress, we're going to use that equation for a rectangular cross section, which is going to be 3 divided by 2 times the shear stress divided by the area. And notice this area is a function, so I can call functions within functions. And so I'm calling this area right here. It'll go through and calculate it right here for me. And so I define that, and now we're going to define our bending stress. And we're going to call this the max bending stress. And so it's going to be equal to the bending moment. I got to use self. Remember that. A lot of times you'll make that mistake, is you won't include self, and then Python will scream at you and throw errors, and you won't know what to do. But remember to include self times the thickness divided by 2, because we're calculating it at the top of the beam, or the top of the cross section. That's where our maximum bending stresses occur, is the at the bottom and top of the cross section. And then I need to make this negative. Times self dot moment of inertia. So guys, that's our first class. You can see here we have the components. We got parameters and we got functions. We got our instructor. Same as our UML diagram. And so we've done it for one. And so this is an example of the rectangular cross section. And so now I'm going to pause the video and just bring in the rest. And if you need to look at the code, look at it on my website. It's there. So I'm going to pause the video real quick and get that other stuff in here. So I went ahead and completed coding the other two classes. So this has everything that was in our UML diagram for circular stresses, for circular objects and circular tubes. And so I wanted to point out before I went on that we're using a package. So we're using the math package to acquire the value of pi used in calculating area and moment of inertia of our circular and circular tubes. And so Eclipse is going to throw an error at you here saying basically, you know, there's an undefined variable. So what you do to pull in that math package is you press Control-Shift-O, and it'll say, oh, what should I import? Well, I want to import the math function. And then I do, and bang, it imports it and puts it at the top as shown here. And then my errors are gone. So we're done. So this is it, guys. I completed 3 classes. Now let's go figure out how to call these so we can perform some calculations. So I'm going to pause the video and get that set up. So to test these classes out, we got to create a new module. So if we go to our package, and I forgot to mention that this isn't going to work because our package is the same name as our module. So let's go ahead and change this name so we can avoid errors in the future. So just click on your package, press F2, and rename it. Just say, call it bending stresses CC, or CS for cross sections. Press OK. That's our package, and now we're going to create a new module in our package. So right click, go to new, press other, go down here to PyDev module and rename it test bending stress. Click finish. I'm going to use an empty template, and so let's test this out. So what we're going to do first is we're going to assign a variable to one of our classes. So I'm going to use variable x and then call the rectangular stress. And you can see it auto-completes. It found the class right there. If I press enter, it'll complete it, and it'll also import the package and the module. So that's convenient. And so I'm going to put parentheses here and then press Control Space. It'll tell me what fields I need to fill in. So I'm just going to put in random numbers right now. 3 as my width, 4 is my thickness, a bending moment of 20, a shear stress of 10. And so what we do next is we can access fields within that object by doing the x dot notation. So x dot, we can calculate, print out the area. So that should be, you can see here 3 times 4, that should be 12. Let's see what we get. Python run, bang. And in our module we get 12, so we know we're right there. We can also print out the maximum shear stress. X dot maximum shear stress. Press enter, Control Space. Actually, that's a function, so it'll return that value. We can also do the max bending stress. Max bending stress. Bang. And so if we run this, okay, so I'm getting an error here. So this is what coding is, guys. There's a lot of debugging you have to do, but it's saying type error. Int object is not callable. So if we look above that, it says, okay, I see it. Bending moment, that's a parameter. It's not a function. So let's go fix that. So I take away the parentheses, and it should work now. Save that and then run it. And bang, we get our values. So now what I can do midstream, since we have made it a class, I can change a parameter. So instead of having a thickness of 4, I can change it. And how I change that is I access the parameter in there. So I'm going to access the thickness parameter. So I use the x dot notation, and I set it equal to 5. So let's see what happens. Press play, and so I can change any parameter, and you can see even though we have 3 and 4 up here, we changed it to 5, so our new area should be 3 times 5, and looky there, it's 15, 3 times 5, so it changed. And also our max shear stress and max bending stress updated with it. So that's the benefit of object-oriented programming, is you can change things on the fly just by accessing the class parameters through the dot notation as shown here. So what I'm going to do next is I'm going to just pause the video and put in all the others so I know it works. So I've coded the rest for the circular stress and the circular tube stress, and so what we do next is just to run to see if it works. Run the values. I should get 12 values. I printed out area, max shear stress, max bending stress, and moment of inertia for each of these, and I get those values. It looks like I have no errors, so we're good to go. And so now the next step you want to do is you want to cross-validate your results. If you're going to do engineering programming in general, you have to cross-validate your results. So I'm going to basically comment these out below it and save this. And so I'm going to go online to a calculator. And so this is the calculator I'm using right here. It's at amesweb.info.com. And so you can see here they have built a calculator to calculate stresses in a rectangular cross-sectional beam given the height, width, and or thickness with shear force and bending moment. So that's the same parameters we have, and then it calculates these cross-sectional area, moment of inertia, shear stress, maximum shear stress, maximum normal stress, and so we're going to do that here. So I'm going to switch these around so that I have them in the order I want. Bang. So it's going to go area. It's going to print it out in area, moment of inertia, max shear stress, and max bending stress. And so I forgot to mention that in the code I went and changed these to the max bending stress to the sign convention I use. I apply a negative, so I'm going to have to apply a negative moment of inertia up here. But what you have here is we're going to put in these same parameters, so I've already kind of done that, but we're going to redo it here. So control space. So it asks for my width. My width's going to be 5. And my thickness is going to be 10. My bending moment is going to be 1000, but I'm making that negative for my sign convention, negative 1000, and then shear force equal to 100. And so bang, we have it. And so we calculate that. It's going to calculate the values. Let's see what we get. So we can see here my area, which I printed out first, is equal to 50. Well, the area over here is 50. My moment of inertia is going to be, I use the second moment of inertia. It's going to be 416.667. I calculate that same value. And then my max shear stress is going to be 3. And as you can see here, it's equal to 3 over here too. And then my max bending moment is 12. And so maximum normal stress is 12. So there we have it, guys. This program right here is comparable to a program online. So if you wanted to program a GUI with this, you could. You could build this exact application using this program developed here. So guys, that's it.
There we have it, guys. We applied an example of object-oriented programming to mechanical engineering. As you can see, it was very clean code. If you try to do this with loops and if statements and all this stuff into one long procedural programming list, you can see that it would be difficult to keep track of everything. Object-oriented programming has pros over procedural programming, and that's why I showed you guys how to do it today. By no means am I an expert in object-oriented programming, but I know enough to be dangerous. And I hope you learned something today. So guys, if you liked the video, please subscribe, and there's more to come. So I'll see you in the next video. Adios.